Hello everyone. In the previous video we have learned about the laws of indices. In this video we are going to learn about the applications of laws of indices. It means we will be discussing some of the problems which are based on the laws of indices. These problems are not only of the school level, they are also important for the competitive exams and even for CA foundation. When we start, the first problem here is x power n power n minus 1 upon n and whole power is 1 upon n plus 1. When we want to simplify, we can write this as x power n, and if we take the LCM n here, this becomes n square minus 1. Whole power 1 upon n plus 1. We know that these powers will be multiplied because we know the rule x power n is equal to x power m into n. So we can do it now. X to the power n into n square minus 1 upon n and whole power 1 upon n plus 1. This n and n cancel. And again the same thing we will be applied here. Will we get here x power, if we make the factors of n square minus 1, that is n minus 1 into n plus 1. We know a square minus b square is a plus b into a minus b, into 1 upon n plus 1. This n plus 1 and n plus 1 cancel, and we are left with x power n minus 1, which is the answer to the problem. The second problem we discuss here is x power a upon x power b whole power a plus b, x power b upon x power c whole power b plus c, and x power c upon x power a whole power c plus a. We know that x power m upon x power n, that is equal to x power m minus n or not. And if we apply that here, will we get here inside the bracket x power a minus b whole power a plus b. Here we will have x power b minus c and whole power b plus c. And here this will be x power c minus a whole power c plus a. Applying this, x power m power n is equal to x power m into n. Do we get here x power a minus b into a plus b? This is x power b minus c into b plus c, and this is x power c minus a into c plus a. We apply here the formula or identity a square minus b square is equal to a plus b into a minus b. So this will become a square minus b square, and so on. We are getting here x power a square minus b square into x power b square minus c square into x power c square minus c square. And we know x power m into x power n is equal to x power m plus n. Indices are added. So here if we apply that, will we get here x power a square minus b square plus b square minus c square plus c square minus a square. We find here this a square cancels this, c square cancels this, and b square cancels this b square. We take x power 0. And we have already learnt power 0 of any number is equal to 1. So the answer here in this case comes as 1. The next problem we are going to discuss here is 81x power 4 divided by y power minus 8 whole power 1 upon 4. If we simplify this, we will be able to write 81x power 4 into y power 8 whole to the power 1 upon 4. Why? Because we know that x to the power minus m is equal to 1 upon x power m. Or we can write 1 upon x to the power minus m as x to the power m. That's what we have applied here. Can we write it as 81 to the power 1 upon 4 into x to the power 4 to the power 1 upon 4 into y to the power 8 to the power 1 upon 4? Why? Because we have learned that x into y to the power m can be written as x power m into y power m. And we know 81 is power 4 of 3, 1 by 4, into x to the power 4 whole to the power 1 upon 4, into y to the power 8 into 1 upon 4. And we know these powers are multiplied. As we know that x power n is equal to x to the power m into n, so will these powers be multiplied? So we are getting here 3 power 4 into 1 by 4, x power 4 into 1 by 4, y power 8 into 1 by 4. This cancels this cancels this, and this cancels this twice. Are we getting the answer as 3 into x into y square or not? Which is the answer to the problem. Now the next problem we have, if a power x is equal to b, b power y is equal to c, and c power z is equal to a, then what is the value of x into y into z? What we do in such problem, since we have c power z is equal to a, and we know the value of c is given in this, we have been given b to the power y is equal to c. If we substitute that value of c here, will we be getting b to the power y to the power z is equal to a? And we know this will be multiplied, so we can write this as b power yz is equal to a. Now from this we know a power x is equal to b. It means we can substitute the value of b here. So will we get here a to the power x whole power yz is equal to a, and these powers will be multiplied because we know that x to the power m power n is equal to x power m into n. So will we get here this is a to the power x y z, and this a means if we write this as a power 1, and we also know that if we are having somewhere x to the power m is equal to x to the power n, this implies that m is equal to n. Applying that, will we get here that x into y into z is 1? This is the answer to this. The next problem is, if 2 power x is equal to 3 power y is equal to 6 power minus z, then what is the value of 1 upon x plus 1 upon y plus 1 upon z? See here, we consider in such cases that each value is equal to k. Suppose this law. Then we are getting from the first one 2 power x is equal to k. So can we write that 2 will be equal to k to the power 1 upon x or not? Because we have learnt that root of x is equal to x to the power half. It means nth root of x is equal to x to the power 1 upon n, that we have learnt. Similarly, from the second one, we are getting 3 power y is equal to k. It means 3 is equal to k to the power 1 upon y. This 6 power minus z is equal to k. It means 6 is equal to k to the power minus 1 upon z. Now here, can we write this 6 as 2 into 3? 2 into 3 is equal to k to the power minus 1 upon z. We know the value of 2 from here, that is k to the power 1 upon x. And the value of 3 from here is k to the power 1 upon y. So we substitute k to the power 1 upon y is equal to k to the power minus 1 upon z. We also know that if x to the power m is equal to x to the power n, it means m is equal to n. So will we get this power and this power will be equal to this? And we also know that x power m into x power n is equal to x to the power m plus n. So these powers will be added. So we are getting here k to the power 1 upon x plus 1 upon y is equal to k to the power minus 1 upon z, which gives us 1 upon x plus 1 upon y is equal to minus 1 upon z. If we transpose, are we getting 1 upon x plus 1 upon y plus 1 upon z is equal to 0. This is the answer to the problem. The next problem we have x power a upon x power b whole power a square plus ab plus b square, x power b upon x power c whole power b square plus bc plus c square, and x power c upon x power a whole power c square plus ca plus a square. To find the solution of this, can we write here x to the power a minus b? Because we know that x to the power m upon x power n is equal to x power m minus n. We also know that x to the power m whole power n is equal to x to the power m into n. If we apply both here, will we get this power and this power and multiply? So we can multiply it here, a square plus ab plus b square. Similarly, here we can get x power b minus c whole power b square plus bc plus c square. And here we get x power c minus a into c square plus ca plus a square. Now we also know that a minus b into a square plus ab plus b square is equal to a cube minus b cube. If we apply this identity here, are we getting this as x power a cube minus b cube? This is x power b cube minus c cube, and this is x power c cube minus a cube. And we also know that x power n into x power n is equal to x power m plus n. Powers are added. So if we add the indices of the powers here, are we getting x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube? This a cube cancels this a cube. C cube cancels this c cube. And b cube cancels this. Are we getting x power 0? And we know x power 0 is always equal to 1. This is the answer to this problem. So in this video, we have learnt how to apply the laws of indices to various problems to find their solutions. In the next video, we are going to start again the next topic, and that is on ratios. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.